Well, as I mentioned in the previous few videos, there are about a dozen programs that exist in the system dynamic space. Simulink, which dominates engineering, VisSim, which I think is a better package for engineering modeling. Then you have things like VenSim, which is, in my opinion, a pretty kludgy program to simulate dynamics, but it dominates the management and marketing and general system dynamics community for modeling. So they all exist. What does Minsky add that's special? It's this thing over here we call a Godley table, after Wynne Godley, the person who invented the idea of, along with Francis Cripps, invented the idea of stock flow consistent modeling. So if I click on that table, I create a Godley table, which is shown as a bank icon initially, and I can, once I click on the screen, that is placed on the screen. That is designed for modeling monetary flows. Now, I could again try to model monetary flows using the flowchart dynamics, like as I've shown you a moment ago. Let's bring up, let's probably go on predator prey. Hang on, that'll do. I could try to model it using the wires. There's no problem in doing that. I could just have bank accounts rather than predator and prey and stuff like that. But what I found when I tried to do that was that I always make mistakes with the signs of the variables, because if you're transferring money from one person to another, you have to reduce one account by as much as you increase the other. Now, when you're wiring up a flowchart, it's easy to define one variable and have the wrong sign, or not actually wire up the dynamics. You don't necessarily ensure consistency between your bank accounts. So I realized at some point that I could develop those models using a table, which I used to generate in MathCAD, and that was the impetus for designing Minsky, that let's make a software package that has these double entry tables built into them. Now, I better make one point. When I first invented Minsky, I did not understand the importance of double entry bookkeeping. My tables could be single entry or double entry depending upon what I was looking at. And as I started to use Minsky, I began to realize how important double entry bookkeeping was for showing all this. So Minsky actually still potentially supports a single entry table, but I don't recommend using it. And in fact, as soon as we can, we're going to be removing the capability to have single tables and make everything being double entry. But let's open up the table and see what you get. You get a spreadsheet like this, and again, I've got to zoom in. I don't have the capacity to zoom. Hang on, let's minimize this one. Okay, I don't have the capacity to zoom in these tables. So you have stock variables being shown off to the right hand side here, flows being shown down here, initial conditions, and a button you have to click on to say whether you're talking, I'll show you here, about an asset, a liability, or equity. Now that will go at some point. It will have defined columns, assets, liabilities, and equity. But this is still we haven't yet quite got rid of this relic of me not understanding double entry bookkeeping. So let's actually choose and say this is going to be an asset, and I'll say reserves of the asset. Add another column, and I'll make another column which are asset calls say loans. Again, this is one of the problems with the Unix Linux base of the program. Things go where the cursor is rather than the one you've tabbed into. So I've just got to make sure the cursor remains over here where I want to type loans. It moves around, as you can see. The focus changes. So I'm typing loans there, and then I'm going to have liability, and I'll say firms as a one deposit account, workers as another, and then I'll finally add a column for the bank itself. I have to just drag that window a bit wider so you can see it, and I'll say this is equity, and I'll call it the underscore curly brackets bank for equity. Now, having done all that, let's say there's initial reserves of 100. Let's just tab over here and see what's happening on the palette. You can see that those stock variables are now sticking out the bottom of the bank icon. Let's keep on going. And once I type in 100 as reserves and say 1,000 as loans, then what Minsky is doing is checking and saying, well, your initial conditions have to sum to zero in terms of accounting, but assets minus liabilities equals equity. If I've got 1100 in assets, I have to have a matching amount in liabilities and equity for the equation to be balanced. At the moment it's not. So let's say firms have 800 in their account. If I press the side, if I have the sideways arrow, go to the next one. Let's say workers have 200 and banks have 100. Now Minsky is saying assets minus liabilities equals equity is correct, so the row sum is 0. This is a major, even though we're stuck with the old third party spreadsheet we're using for the Godley tables, we've changed the logic. This is actually Russell's own initiative. We used to define assets as positives and liabilities and equity as negative as a convention, so that you'd have positive numbers over here, negative numbers for here, including equity, and the sum would be 0. Now what we've done is we treat everything as positive. We make sure the equation is still fulfilled in the background, so that assets minus liabilities equal equity, but they're all shown as positive, and that changes how you actually enter different financial transactions. I'll show you this now. Let's say you have the banks lend money. So let's say what I have here is the word lend, which is going to increase assets. It will also increase liabilities. And that's fundamentally the reality of what we call endogenous money, or what I prefer to call now bank-originated money and debt. So that's lending. So you have interest payments. Well, that's going to be payments from the firm. So it's going to take money out of the firm bank account and add it into the equity of the bank. Now that's a change from the previous version of Minsky, and I think people who are currently using Minsky will get their head around that very rapidly. I think for people who haven't used it before, this is quite intuitive. Something that increases assets as a positive, reduces them as a negative, and the same story on the liability side. But let's now, I'll just put in repay debt. So that's going to be, if you repay the debt, you're going to reduce the amount of money in your deposit account. And you're also going to reduce the amount that you owe to the bank. Now let's add a few normal transactions between parties here. So you're going to hire workers, so you have to pay a wage, and that's going to be money coming out of the firm's bank account and going into the workers. Again, this could expand the window to see the extra row that I'm trying to add here. So if I have workers consume, that's going to be reducing the amount of money in the workers account. I'll use const underscore W to get a lowercase a subscript to W there. That's going to increase the amount of money in the firm's account. And let's have the bankers consuming as well. This is the simplest model that I build when I'm trying to explain monetary dynamics to my students. Okay. Of course, you can make a more elaborate model than this, but this is the basic idea of a model, of dynamic model of monetary flows. And that's going to, now I've made a mistake there, but I'll stick with the mistake. That's going to increase the amount of money in the bank, in the firm's account. Now I've put the wrong sign there. I haven't got a minus in front of the consumption for the bank. So I told Minsky saying rather than row was 0, it's actually equal to minus 2 times consumption by the banks. And that's Minsky working in the background to work out what the logic actually is here. So I need to have a minus consumption by the bankers. And I'm moving around here by holding down the control key and pressing the sideways arrow. That's how you edit within a cell. And then bang, you get that result. One more thing you can do, if you put stuff in the wrong location, of course this is in the right spot, but if you click and drag, you can move an entry from one cell to another. And of course that's still got things in the right location. The row still sums to 0, but of course that's in the wrong spot. You'd rapidly see it if you tried to simulate the model. So you can make stock flow errors with Minsky, but it makes sure that when anything, as Goodwin Godley used to say, any float starts somewhere and goes somewhere. So that's showing the basic logic there. And I'll just call this banking ledger, to show that's the banker's view of the economy. I've got to type the enter key here to make that wake up. Okay, so what have we done with all that? Let's look at the equations we've defined. Now you notice I didn't type a single integral sign or differential equation and all that. I've just simply said what are the flows between bank accounts. What Minsky has done is create this set of differential equations. Equity of the bank is interest minus consumption. The rate of change of the firm's deposit account is lending plus consumption by workers and bankers minus interest payments, repayment of debt and wages. Loans are increased by lending and reduced by repayment, and workers' accounts are increased by wages and reduced by consumption by workers. So that's the beauty of Minsky. In that sense, you defined a set of differential equations without even knowing you're doing it. And once you've done that, you have to, of course, define the variables inside here. But I'll quickly show one other feature of Minsky as well, and that is that that's seeing the economy from the point of view of the banking sector, but you would also want to see it from the point of view of the firms. So I'll just actually type firms here. And to do that, click on No Asset Class, go for Assets. The down arrow here will check for any liability that currently hasn't been allocated as somebody's asset. And click in there, you'll find you've got firms and workers. So once you click on firms, all the operations that are being done for firms are currently brought across. You need to then check any liabilities, and now Minsky will look for an asset that hasn't been allocated as somebody's liability. There are loans and the reserves there. Click in loans, and you can see that all the operations that existed for the firm's account has been transferred across, and ditto for the loans, and they're put on the correct line so that those two are summing to zero. Now, of course, what you need to have to complete the whole system is to have the equity of the firm sector. So I'll call this E underscore F since I've E underscore firms since I've used E underscore banks for the banking sector. And now I've got to type in and say what the overall equity is. Now notice what's happening here. Firms have got assets of 800 but liability of 1,000, so they've actually got minus 200 as their initial condition. Pardon me, 200. Okay, that's wrong. I need a minus key there. Equity starts negative, and they can do that because even though they've negative equity, they're financing themselves out of the turnover of their bank account, so they can pay their bills out, as I'll show you when I want to make a simulation out of this, as and when they fall due. Now, consumption by bankers adds to the equity of the firm sector, as does consumption by workers. Interest payments reduce it. Lending and repayment already covered, and wages reduce the equity. Paying wages reduce the equity of the firm sector. So now we have a balanced view of the economy from the point of view of the firm sector as well, and we can do the same for the workers. So let's double click here, call this workers, check and see what the assets, make it into asset classes first of all. There are workers, there are their operations, they don't have any liabilities, so I can leave this stage out at the moment and call this E underscore. Notice again I've gone to the focus has gone to the wrong spot. Just make sure your arrow key is in the right area. We'll work on that. Workers, close curly brackets. Now of course they have positive equity, so they don't have to go assets but no liabilities. Consumption reduces their equity, and wages increase their equity. Okay, and then we come down here. Now you can see all those operations shown from the point of view of the three sectors in the economy, all consistent, and these are your set of equations you've defined. Again, let's just drag that over here so you can see them. So that's a lot of writing of differential equations with not even needing to know that you've done it. And the next stage is to actually make those into defined flows, because at the moment no flow is actually being defined. So let's just use another feature of the new version of Minsky. I can copy these one by one. What we now allow you to do is copy all the stock variables and all the flow variables. Let's copy the stock variables first of all. You get a group. And I won't talk about groups in these videos. We're still working on defining groups properly. But that's copied all this lot here as a group. And if I choose ungroup, wait a few seconds. Tick, tick, come on. Okay. Again, some inaccuracies where we locate that stuff. But there's all these are now shown on the palette. And let's copy the flow variables. Same story. Make them over here. Choose ungroup. Wait a bit. Okay. Now let's actually define the easiest of these, which is interest, is the level of loans multiplied by the interest rate. So I'm going to say we have a R_L as the rate of interest on loans. Didn't actually make any problem there, but that is we get another little bug we've spotted. Make this into a parameter. Give it a value of, say, 0.04 and a maximum of 0.2 and a minimum of 0.01 with a step size of 0.01. And now if you multiply loans by the rate of interest, you get what interest is being paid. And that, as you'll now see, that equation is now part of the system. And as I keep on defining all these flow values, I'm ultimately going to define a very simple dynamic model of a banking sector. So I might just keep on going. It's not, that won't take me too long to do it. So if you want to take a break and get a coffee and fast forward, you can, of course. But I'll just define how much lending occurs and say there's sort of an exponential relationship in lending. So lending depends upon the current value of loans, and loans are here. Let's take a copy of loans. And now I'm going to just again display one more feature of Minsky, which anybody's used is familiar with. Because it supports LaTeX, which is a mathematical programming language rather than a strange substance one buys for various reasons. If you type a / key, then Minsky knows you're about to type a defined character using English language text to generate a Greek or a Chinese or whatever language statement. If I type tau, I'm going to get the letter tau, curly brackets, _L. That will now give me the Greek letter tau. Again, I don't know why the bug is turning up. That's one for us to look at. There's tau L, which is the time constant for lendings. Let's actually go inside here and edit that. I'll make that into a parameter as well, though it could be defined by the system. And what I'm going to say is how many, time constant is something that's used regularly in engineering to say how long, roughly how long does a process take, of exponential decay take to halve the value as a variable. It's actually reduced it to 63%, but that's the rough idea. So you're saying how long does it take, for example, if you're adding new loans at a particular rate, how many years does it take to double the amount of outstanding loans? Let's say I leave a value of 9 there, and say a maximum of 20 years for very slow lending, a minimum of 3 for far too fast lending, and a step size of 1. I've now defined this. Hello, that shouldn't have happened. All right, we have another bug. I'm going to save this very quickly and see what the hell happened there. So this is partly introducing a new version. The new version has bugs, but I'll save this anyway to a YouTube. So I'm going to actually save this model first of all. And now go for a new system and now load that model. See what's happened. Okay, I've lost that constant. I'm not quite certain why that happened. Let's see if tau L is actually defined amongst the equations over here. And looking through it, tau L somewhere disappeared. Okay, I'll leave this in here because you are going to have to cope with bugs in Minsky until such time as we get enough funding to knock off all the problems. So tau L somehow managed not to get defined and all that. So let's actually just define tau L again. And I'll just, here we go, /tau _L for lending. Same error message. Okay, what I might do is save it at this moment and shut Minsky down. This is some of the things I do to get around some of the bug elements that occur here. Let's actually now reload it. Now hopefully that problem won't recur. Accidentally brought down a chart, but I'll need charts later, that's okay. So I'm going to have tau-L. Let's actually edit it and see what the values are. I want that to be 9 with a maximum of 20, minimum of say 4, step size of 1. Now that's correct, and let's just edit and also say it's a parameter. And now divide loans by the time lag for producing loans, and you then have the rate of lending. Now let's just take a look at that equation over here. So there's the equation I've just defined, that the rate of lending is the level of outstanding loans divided by the time lag in years for the number of years for the loan will take to roughly double. Okay, now why not do something quite simple by multiplying by a constant? Well, there's two reasons for that. One, the constant itself has no obvious time dimensionality. It's actually the inverse of how many years it takes for a dynamic system to double. The second is that economists looking at it will get disturbed. So I first showed Minsky some years ago to my good friend and colleague and occasional jousting partner on tennis courts, thank God not on fencing, otherwise I'd be dead, Mark Lavoie. And Mark looked at the number I had for how fast workers consume, and I had a value, I think, of something like 26. Well, what that said was workers turn over their bank accounts 26 times a year, which equally is saying workers exhaust their accounts if they haven't got any other cash flow coming in 2 weeks. So one is it will give you a number which looks quite strange, hard to explain. The other gives you a number which is based on the time dimension of the model. So if I have talked about how fast workers consume and how fast bankers consume, I'm going to have a much smaller time constant for workers' consumption because they can go a lot less time without running out of money. So that's why I use time constants. Again, I recommend take a look at the, let's take a look at the Wikipedia page on that. So I go to Wikipedia and probably get the warning. Bill White. No, sorry, pardon me. I meant Wikipedia, not Bill White, my good mate Bill White. Okay, Wikipedia. So now if I search for time constants here, or time constant, you'll get an explanation of what they're used for, and I highly recommend reading that to understand why you use time constants, why they're preferable. You don't have to use them, but why they're preferable to using rather than using simple constants. Okay, so I've now defined lending. Equally, I need to define repayment. So let's just grab repayment here and use a similar sort of idea. Say that repayment's based on the current level of loans, and there's some time constant for repayment, tau, which is the Greek letter for T, underscore R. Now, click on OK. Same error message. Okay, we have a bug there to track down. But there's tau-L. I'll now try to edit that and give it much the same value. So value also of 9, 20, 4, and 1, and make it into a parameter. Now I hope nothing goes wrong here. Okay, divide by, drag that, drag that, drag that. Yeah. Now I want to have consumption. I want to define consumption by workers. I'm going to base that on what's in workers' bank accounts and say there's some time constant. So same story, tau underscore, and I'm going to have consumption and then uppercase W by workers. Same error message. Place it here, edit. Give that a value of 0.04, which is roughly, roughly 1/25th or so of the, okay, 1.02. So roughly every week they run out of money. Let's make it every 2. 0.004, pardon me, is roughly 0.04 of a month is roughly a fortnight basis. They run out of money on a fortnight basis. The maximum they could survive for is, say, a third of a year. The minimum might be, say, just for a few days, and give it a value of 0.001. We may at some stage introduce dimensioned values here, so I actually have that in terms of weeks, quite possibly. I'll make that a parameter. Let's just edit that and make it into a parameter. And then divide by. And the same for consumption by bankers. Much the same idea. I'm making a mess here, but we can fix up the value later. So we need to have the equity of the bank as the basis of their consumption. Let's just drag it over here. Tau underscore consumption uppercase by bankers. Same error message. Click on OK. Place it here. Right click, edit. Give that a value, say, of 1, maximum of 3, minimum of 0.5, let's say. Step size of 0.01 will do, and make it into a parameter. Divide by. Okay, there's only one thing left to define, and that's wages. Now I'm going to base wages, and this is where it gets that amount of economics turns up. What is GDP in this model? Well, GDP, I changed the value of wages unintentionally just then. So if I can actually edit and go back to 0. Okay. What is GDP? In this model, it's the turnover of the money in the firm sector, because that's what people are spending money on. There's nothing else to spend the money on in the system. You're buying the output of the firm sector. So I look at the turnover of the amount of money in the firm sector. That is going to give me GDP. That's the first stage. So I have tau underscore F for the firm sector. Right click and say, for example, that the firm sector turns over the amount of money in its account, say 4 times a year. I know that's too fast, but it's just to make an illustration. And say the maximum might turn over, say, 6 times a year, minimum 2 times a year, and give it a step size of 0.5. So the turnover of money in the firm's account will give you GDP. So I'll just type GDP here. I could type Y obviously, but I'll stick with GDP. Click. So that's total turnover by the firm sector. And now, what's the share of income going to workers versus capitalists? Well, I use S as my symbol for the share going to the capitalists. So I type S here. Same story. Click, place it here, edit it. Make it a parameter. Say that 30% roughly of output goes to capitalists, maximum of say 0.6, which we seem to be heading towards, minimum of 0.3, step size 0.01, that will do. So I now multiply GDP by the fraction that goes to workers, to capitalists rather, and that then gives you profits. And I'll use backslash key, capital PI, which is the Greek letter for P, which is pi, profits, and say that's equal to profits. This is a very simple model. I haven't got any causal dynamics, any feedback as I have in a Goodman model or a Minsky model, but again, it's just to get a very rapid illustration. So that's profit share. Well, what the residual is going to go to workers. So if I have a minus here and say there's GDP, hang on, minus profits is equal to wages. So workers get the leftovers. Okay. Now let's just save this model and check the equations. And there's everything defined. And notice that everything, just looking down that list, everything has a value. the rate of lending and rate of repayment are the same. Firms turn over the amount of money in their account 4 times a year. Workers consume the balance of their accounts every 2 weeks. Bankers take a year to be in the same situation. 30% of the GDP goes to the capitalists, and the interest rate is 4%. And these are the various flows defined I've already done, and these are the differential equations of the whole thing. So we have liftoff as a model, and let's just make this a bit bigger to resize. Let's graph a few things here. So let's graph. Let's graph the amount of money in the bank accounts first of all. So we have loans here. My mistake. Oh, great. I thought I was highlighting again. The wrong thing was deleted, so I want wages there. So let's just make a copy of wages over here. Now notice that's okay. You would have noticed when I brought it across, this is coming out vertically. Again, we have to fix that particular little issue. It's not a major problem, but it's just a again something you want to fine tune. So click a copy here of loans, graph loans against the black up here. Now we're going to graph the amount of money in, where's the firm's bank account. Workers' bank account. And the banker's equity account. Have I got that? Yep. Okay. Very sensitive where the cursor is currently highlighted, so copy. Let's just call this bank accounts. We're now working in years, and this is in dollars. Okay, save it again. Let's run it. Now, there's a tiny amount of reallocation of money in the accounts there. Nothing much happening, but what happens if loans happen rather more rapidly? So rather than taking 9 years to double the amount of loans in the banking account, you actually have 8 years. Well, the bank accounts rise. And then if I go back to the same level, they stabilize again at a higher level. So we've created money, and by creating money, we've also created additional GDP, which is why all this stuff matters, because you have a change in the amount of lending, changing the amount of money in circulation, and leading, therefore, to additional demand, which is the whole point I've been trying to make in my debates with 1P Krugman, which he doesn't understand yet. Okay, so we have GDP and incomes. So this is in years, and this is in dollars per year. So we're talking a flow here. Let's make this larger. And let's actually graph the other elements here. Let's have wages, copy that. Down here. Profits, that's pi. And now interest payments times loans are, of course, the banker's incomes. Let's take a copy of that. And now let's actually vary the rate of lending. So if lending happens more rapidly, GDP and income rises. If lending happens more slowly, they're going to fall. So there's a relationship between bank behaviour and level of GDP, which is the point people like myself have been trying to make the neoclassicals for 50 years, but now I can finally make it pretty rapidly with Minsky. So let's just actually do a bit of tidying up here. This is all very messy with all the parameters scattered all over the place, so you can just basically take a copy of them and place them up the top here, which I do for, pardon me, I do this for neatness in all my models. Pardon me, let's go back to 0 scale. Drag this up a bit. I want to take a copy of tau L. place that there for the moment, and then drag it up here. Obviously, I'll spend a fair bit of time tidying this up later. There's the time consumption for constant for consumption by workers. There's the one for bankers. So I think it's only those, and also the rate of surplus, distribution of GDP between workers and capitalists. Place that there. Notice the scale is different. I'd change the scale at one stage, zooming in and zooming out. That's another bug we have to get fixed up because they all should be the same size. So I'll just actually quickly save that, shut it down, and open it again. And you'll find all those things the right size. And I'm now going to go back and tidy it all up. But that's the basics of building a monetary model in Minsky. Now what you've built, even though it's extremely simple, is an extremely relatively complicated model of the differential equations, the flows between bank accounts, but it's still a toy model. This is not a model of a serious economy. And I knew that Minsky could not be used to build a model of a serious economy because when you do it, what you get is a whole mess of wires all over the place. And what I want to do instead, again, dependent upon getting more funding, is have another tab here where the equations can actually be entered in a tabular layout, and then you can control all those various parameters in one go. You can change the initial value, the maximum, minimum, step size, etc., whether something's a parameter or a variable, the equation that defines it if it's a variable, all that on one tab. And that would mean all this stuff here would just become ultimately just these three Godley tables and the graphs you want to show, because all the logic is stored inside the Godley tables. So I knew you couldn't make a serious model of the globe, of any economy using Minsky. Unfortunately, Pedro Pratas, who's now my PhD student, working at the Portuguese Statistical Agency, didn't know that, so he did it. And I want to show you, it's a mess, but I want to show you that with this, Minsky can actually do a decent model, a monetary non-equilibrium model of an actual national economy. So let's take a look at this. It's a mess, but somehow Pedro managed to keep the whole thing properly defined. It'll take a while to load. Quite a while. Yuck. Okay, but despite yuck, this is a more accurate model of the Portuguese economy than the DSGE models used by the central bank and the Treasury in Portugal. It's actually fitted to real data. I'll just actually zoom in there and see if you can actually see what that actually stands for. You can basically make it out. That's gross operating surplus. Let's actually zoom in a bit so I can actually get a bit more resolution here. I take my hat off to Pedro for being able to work this on what would be a much more lower resolution screen than I'm working on right now. But this is a part of the program I haven't explained so far, and I will do so later. But this is bringing in data, current and capital transfers, which is brought in as a CSV file using, let's see which operator it is, this operator here, which is data input. So it's still very simple. We have to import a CSV file, but Pedro has shown you can actually fit a discrete data, collected data to a continuous time model and get a very accurate model of a national economy. Let's go back to zero scale again. Zero scale. I need to be actually lower scale than that. It's just too hard to see everything on screen. That's actually showing the full scale resolution of the program, and you can see how much detail is in there. And notice this is defining the government deficit. That's the sort of thing you'd rather than having to use the flowchart to define it, it'd be much better defined on a separate tab. So hopefully I'll get enough funding to do that one day. Well, let's actually show the model actually runs. Based on real data. The graphs are tiny, and of course the whole idea in Minsky is to make the graphs the visual feedback as to how the model's behaving. For the sake of the politicians you actually want to have doing this work. But at the moment what I can show is that Minsky can support everything up to and including a scalar model of a national economy and fit it to data and do a simulation and you can then test the impact of different policies and so on. And that's what Pedro is now doing as my PhD student. Okay, so you can't actually see any change in the variables yet because we're talking a very small amount of time. So far I've only gone through basically 1/3 of a year. But you will see, because this is all fitted to data, you will see those charts moving at some point in time. It may take too long to make it necessarily worthwhile to stop and look at the models. I'll just zoom back out again, zoom out to get oh, here we go. You can see that that particular chart here is now changing with respect to the data. And all the variables, the values are changing. Again, it's hard to see them because of both the scale and the fact that they're some of them some extremely large numbers shown with the exponential notation. So this is, Minsky can actually model a national economy and graph it and show it to policymakers. At the moment, I wouldn't show this policymaker, they just run in horror at looking at this, but the idea is ultimately to make it possible to show them a model like this, take them through the logic of the 5 tables in the system. So this is government, households, productive sector. This is the financial sector over here. Let's just drag it over and take a look at it. Financial sector there, and Pedro's also brought in the rest of the world as another sector. So the idea would be to be able to show a politician the various elements, explain the logic of each row, get them to say, yes, okay, that looks valid to me. Now run the simulation and try your policy, and you might get an impact. I don't know whether this is actually graphing here, but you might get an impact like this, and some important policy variable the politician thought would go the other way. So that's a pretty fast introduction to Minsky. At some stage we'll get around to writing a manual when I have time, or when I find somebody I can hire to do it for me. I have a thought on that front. So Minsky is available for use. You can do everything up to and including modelling a national economy with it. I would advise using it for toy models right now, which can be mixed financial and physical models. I'll show you one of those before I terminate the discussion. I don't think I've actually got that. Maybe I do. Let's see. Okay. This is a model of my Minsky model of the economy done as a set of differential equations. Highly linear. Well, let's actually take a look at this. This one is actually pardon me. Sometimes you'll find as you go over this palette, you sometimes click and accidentally bring down an operator you don't want. I've just deleted that. Just right then. So this is defining the economy in terms of the employment rate, the wages share of output, and the debt to GDP ratio. These are actually derived directly from definitions. So I take the different definitions of the employment rate, which is how many workers have a job divided by population, the wages share of GDP, which is wages divided by GDP, and the debt ratio, which is debt divided by GDP, differentiate them with respect to time, put in the simplest possible linear relations between various entities. So I've got a constant capital output ratio. I've got exponentially growing labour productivity, exponentially growing population, and profits, investment being profits minus wages minus interest payments, and firms borrowing money to invest. So the rate of change of debt is investment minus gross profits. Put it all together, an incredibly simple model, 3 variables, about 8 or 9 parameters. That's the model in differential equation form there. So just those 3 very simple equations. And I explain this in a few of my other talks as well. What happens when you simulate it? You get a complex system. And let's see, I've got this, if I start with a low level of capitalist desire to invest, then you get a model that converges to equilibrium. If you have a higher level of desire to invest, then you get a model that looks like it's converging, only it starts to diverge on the other side. You go from a great moderation to a great recession. Now that's fairly unrealistic because it's a very stylized model like Lorenz's model, which is not to describe an actual weather cell. It's a very stylized model of the economy. Well, let's actually take a look at My mouse is about to die. Good reason to stop. This is now exactly the same model, only I've now included prices in the system, and I now have non-linear relations rather than linear between the variables. Still a very simple model, and what you get out of this is much more complex behavior. This is completely deterministic. There's no stochastic elements inside the model at all. You have a rising level of private debt down here, an employment rate that's going up and down, cycling, a declining inflation rate, interest rate falling as well as the rate of inflation falls, profit fluctuating around, nominal and real growth shown over here, and with the rising level of money going to debt, a rising amount of money is debt, bankers' share is now rising in a cyclical fashion as well, and the rise in bankers' share is offset by a fall in the amount going to workers, which means that profit actually starts to stabilise. It looks like the economy is doing really fantastically, except for workers, but who cares about them? They're getting a declining amount of money, income inequality is rising, but the economy is in perfect equilibrium, except that it's not. And as the debt ratio rises, you actually fall into deflation. So over here we find inflation has now become negative. Debt is now going exponential because it's compounding through deflation as well as compounding by borrowing. Wages are falling, but they simply can't fall fast enough to offset the rise in the amount of money going to bankers. And suddenly capitalists find there's something going badly wrong. Profit share starts to decline. As employment collapses, you're going into a Great Depression. And that's very simply the second stage of building Minsky models. There's a lot further to go, but that just, I hope, illustrates both the capability of Minsky and some rough idea of how to work with it. Please download it, join the beta testing program, find those bugs for us as well, start using it for whatever you do, mathematical teaching, economic modelling, whatever, and we can build a better mousetrap than certainly DSGE models.